Hello everyone. Today in our flipped classroom, we're going to look at multiplying and dividing decimals by integers. Okay, this is the work we've just done over the last week. So a recap, just to remind us of the key points and how we go about multiplying decimals by integers. A reminder, first of all, an integer is a whole number. So we're looking at multiplying and dividing decimals by whole numbers. Okay. Now, first of all, I want you to not be scared by decimal numbers, not be scared by that decimal point, because there's a multiplication sum, a column multiplication. We know that we start by saying 2 lots of 3. And if you're still wobbly on some of your times tables on each screen, I'll just put them here at the bottom corner. So 2 lots of 3 we can see is 6. 6 goes in the answer. And then 2 lots of the 4 tens, 2 lots of 4 is 8. So 8 tens giving us 86. Okay. Now that's the sort of calculation we've been doing for quite a while now. So we should be familiar with the format. But if we do it with a decimal, the actual method doesn't change. This little dot here is nothing to be scared of, because we go through the procedure in exactly the same way. We ask ourselves 2 lots of 3. Now these are 3 tenths, not 3 ones, but 2 lots of 3 is 6. So we've got 6 in the answer. 2 lots of 4 is 8. The only difference is this decimal point. And as long as you remember to bring it down into the answer, 8.6, you are correct. Okay. Everything is the same about these two calculations, with the exception of the decimal point, which, as long as everything is lined up, just tracks down into the answer. Straightforward as that. Okay, let's look at a slightly bigger example. Here we have 243 multiplied by 5. 5 times table here, just to remind you if you're not sure. If you're not sure, these are things you should be learning, but we start here in the ones column. 5 lots of 3 is 15. Our 5 goes into the answer. The 10 comes into the tens column. So we've got 1 10 there, carried across into the tens column. 5 times 4 is 20, plus the 1 we've carried across, so we've got 21. 1 goes into the answer. The 2 tens, in this case the 200s, comes across into the next column. Finally, 5 lots of 2 is 10, plus the 2 that we've carried across gives us 12. Okay, so altogether, 243 multiplied by 5 is 1,215. Let's just alter that calculation a little bit, because this time we're going to do 24.3 times 5. You can see that the digits are exactly the same, 243 and 243. What this means is the only difference is this decimal point. So let's see what happens. 5 lots of 3 is 15. 5 goes in the answer. 1 gets carried into the next column up. 5 times 4 is 20, plus the 1, 21. 1 goes in the answer. 2 gets carried to the next column. 5 times 2 is 10, plus the 2 is 12. There we go, 1,215, the same answer. However, remember, and always remember, we've got a decimal point here in the question. We need to bring that decimal point down into the answer, giving us 121.5 as our answer. Okay. Right. Decimals, same idea. For a little while now, we've become more and more familiar with the bus stop method of division. Here we have a simple example. How many 2s are in 42? Again, the times tables are here if you just need a reminder. So how many 2s are in 4? Well, there's 2 of them. How many 2s in 2? There's 1. Okay, nice simple example. 2s into 42, 21. Now, let's turn those let's convert that sum into a decimal sum. So this time, how many 2s in 4.2? You can see it's basically the same calculation. The only difference is we've now got this decimal. So instead of having 4 tens and 2 ones, we've got 4 ones and 2 tenths, but the digits are the same. How many 2s in 4? There are 2. How many 2s in 1? There are 1. And again, just like the multiplication, the decimal point tracks up, it stays in line. So our answer is 2.1. So apart from the decimal point, the method is exactly the same, nothing to be scared of. Okay, again, slightly bigger example. How many 3's in 2? Well, there aren't any. So I'm going to put a 0 in there as a placeholder just to remind me of where to place my other numbers. Now we've not used this 2, so the 2 gets carried into the next column. So we've now got how many 3's are in 24. How many 3's in 24? Well, there's 8. And then how many 3's in 3? There's 1. Okay. Now I know I put a 0 here. That was just to push all the other digits along so they were in the correct place. But the actual answer is 81. This 0 has no value. It simply works to push the digits across. Okay, so the answer is 81. Let's look at those same digits, but in decimal form. So this time we're going to say how many 3's are in 24.3. We're still dividing by 3, and we've still got 2, 4, and 3 in our calculation. The decimal point is our only difference. And let's see what happens. 3's into 2 won't go. So I'm going to put a 0 in my answer just to push all the other numbers along. And because we've not used the 2, that becomes 24 in the next column. How many 3's in 24? Well, there's 8. How many 3's in 3? There's 1. The decimal point tracks up into our answer. So our answer is 8.1. Again, that 0 isn't part of the answer. It just helps me keep all my answer numbers in line with the calculation. Okay. Right. What about this one? How many 5's in 243? Again, the times table is there just to help you out if you're not sure. 5's into 2 won't go. I'm going to put the 0 in there just to help push everything along into the right place. I've not used the 2, so that's going to join the 4 here. So we've got 24 10's. How many 5's in 24? There's 4 of them with 4 left over. So the 4 comes into the next column, giving me 43 ones. How many 5's in 43? There's 8 of them, and there's 3 left over, giving us an answer of 48 remainder 3. Or if we're going to be more precise, we can divide the remainder by the 5, the number we're dividing by, and say 48 3/5. That's a much more precise answer. Okay. As before, let's turn this 243 into a decimal number. How many 5's are in 24.3? Well, 5's into 2, again, won't go. I'm going to put the 0 in there just to help line everything up. The 2 hasn't been used, so I'm going to take it next door. So I've now got 24 ones. How many 5's in 24? There's 4. 4 left over, so that's going to join the 3 here in the 10th. So I've now got 43 tenths. How many 5's in 43? 8, with 3 left over. Now, this is where decimals can be much more precise, because they just can grow and grow and grow as much as you like. Because by adding a 0, we've not changed the number. 24.3 is exactly the same as 24.30. But what it does mean is that we can put this 3 that was left over. Remember, over here, it was a remainder. It was just leftovers. But here, we can put it with a 0. And so we can ask ourselves, how many 5's in 30? Well, there's 6. We take our decimal and we put it into the answer, and it gives us a precise answer of 4.86. Okay. Now, if there was a remainder here, we could have added another 0 and another and another. Okay, until we got ourselves a precise answer. Okay. I hope all that makes sense. Here we have a selection. Please feel free to pause the video. If you want to check your answers, then you need to find yourself a calculator, either on the computer, on your tablet, or on your phone, or an actual calculator itself. Either way, do which ones you feel you want to practice with and then check them yourselves. Thank you for listening. Take care, and we'll see you all soon.